Welcome, FHS High School. You are listening to the Professor Hubert. Today we're doing learning target. We're going to try dividing. So we're doing the division. There also, you need to know when you do the division, you're really just doing a fraction, which means you need to rationalize the denominator. So right here, remember, square root A, numerator. The B is the denominator. So in the denominator, no radicals. So we can't have a square root in the denominator. So we'll just keep moving on. Make sure you write that down. So what we're looking at is this right here. 15 and 12. So what I would look at is 3. Both of those are divisible by 3. So I'd have square root 5 over square root 4. Notice the other thing I did is something that this picture legitimately told you could do. If it's a square root of the whole thing, you can write it individually. So instead of writing square root of 5 over 4, I wrote square root 5 over square root 4. Square root 4 is a perfect square, so I just have square root 5 over 2, and that can be your final answer. There's no square root down here, so there's no radical. If I look at 21 over 27, I could see both of these are divisible by 3. So square root 7 over 9. If we rewrote that, we could write it as square root 7 over 9. I skipped that step last time, but that's fine. Square root of 9 is 3. So here, both of these worked out well because they're both perfect squares. Well, what happens when it's not? That's when we call it, we're going to rationalize the denominator. Simplify the radical, what we've been doing, multiplying the top of the bottom of the fraction by the radical. Rationals numbers, no non-repeating, non-terminating decimals. So let's look at this. I would write this as the square root of 1 over the square root of 3. Now, newsflash for you, square root of 3 divided by the square root of 3 is actually 1. So multiplying by 1 doesn't change the problem. It's still square root 1 over square root 3. However, instead of writing 1, what if I wrote square root 3 over square root 3? Multiply the insides. 1 times 3 is 3. Square root 9. Beautiful. Square root 3 over 3. Some of you will look at that and you will want to simplify. But those are actually not the same thing, so that is our final answer. Important concepts to understand. Multiplying by 1 does not change the value of the problem. Multiply by this one. Okay, this stuff in the blue box. That is actually equivalent to 1. However, since this trick is useful, because it got us to square root 9, which really is 3. So that's the trick we're going to use to rationalize the denominator, or get rid of the radical in the denominator. So here, 12 and 10 are both positive. I'm dividing by 2. I want smaller numbers. It'd be square root 6 and square root 5. All right. Square root 5 is a prime number. I can't do anything with it, so I'm going to multiply by 1. Square root 5 over square root 5. This is going to equal square root 30 over square root 25. Beautiful. Square root 30 over 5. And that, my friends, is how we rationalize the denominator. So we're going to need a bunch of examples of that, which is good because we got a front and a back to this. So first thing I would do, square root 10, square root 3. I know I need to multiply by square root 3's. We're going to get square root 30 over square root 9. Beautiful. Square root 30 we left on number 2 because I know I can't take anything out. Once you get the hang of some of these numbers, you will too. This one's my favorite because square root 6, square root 9. We're already done. Square root 6 over 3. I didn't need to do anything there. It was simplified. So you're looking for perfect squares. You're looking to simplify. You're looking to reduce, right? Whatever makes it easy for us, that's how we probably want to do it. All right, so now let's go to next page. So the back. Right? Looking at this, square root of 27, square root of 15. I threw the marker. Hold on. Divide by 3, divide by 3. I'm going to write that as square root 9 over square root 5. Right? I should see this as 3 over square root 5. I reduced it well, but it's not radicalized. So get rid of these. This is going to be 3 square root 5. Square root of 5 times square root of 5 would be square root 25, which is really just 5. Done. This other one. Oh, I thought green would work. Square root of 5. I hope you can sense the obvious disappointment in my voice. Here's what I would do. Square root of 4 times square root of 3. Why do I do this? Because I know that would be square root of 5 over 2 times square root of 3. So then the only thing I need to get rid of is the square root of 3. If you can reduce before you radicalize, you're going to see a lot of smaller numbers. 5 and 3 is 15. 2 times the square root of 9. Square root 15. 2 times 3 is 6. So there you are at 6. So that should be a big help for us. Number 9. I'm getting rid of 3. Divide by 3, top and bottom. Alright, you're going to have square root 1 over square root 7. Square root 7, square root 7. Be square root 7 over square root 49. Right, I'm sick of writing this all the time. So at this point, when you see square root 7, square root 7, that should think of yourself as square root 7 squared. Alright, square root and a square are opposites of each other, so you should start knowing that is just 7 every time. Square root 7 times square root 7 is 7. Here, I still would get rid of a 2 to both of these. So I'd have square root 2, 10 divided by 2 is square root 5. Notice, look at this, 2 over 2. That value is actually 1. We're just reducing by 1. But it's easier to write it. Get the square root 5 out here. 2 times 5 is 10. Keep it under the square root. 5 times 5, 25. Square root is 5. I'm telling you, square root 5 times square root 5 is 5. Every stinking time. Alright, moving on. We have a nice little number 11 and 12 with some variables. Not to be alarmed. I do know what I'm doing. Alright, square 3 over square root of 8. Square root of 8, I'd probably write as square root 4 times square root 2, which is 2 times square root 2. Look at that, I already reduced. So I'm going to write 2 square root 2 times x times x times x. Reason for that is I wanted you to see these two can go out front. So we'll cross those off. So really what I have is square root 3 over 2x times the square root. It looks like 2x is stuck in there. So then 2x, 2x. That's going to be square root 3 times 2 would be 6x. Now, square root 2x and square root 2x. Right? You should be comfortable knowing that that is going to be 2x, the first one, and these together would be another 2x. Or you could have thought of this as 4x squared, and the square root of 4 is this 2, and the square root of x squared is this x. Either way, 2 times 2 is 4. X times x is x squared. This needs to be your answer. Now, if you don't understand how I got that, it's probably this bottom line, right? One other way I could have wrote this is square root 2 times 2 is 4, x squared, right? Then you could add 2x, square root of 2 times 4 times x times, what am I doing? Square root 2 times x times x. So you could pull these out. Pull these out. So you have 2x times 2x, which is 4x squared. So maybe that blue stuff will help you. You need to be able to get square root of 6x over 4x squared. This one I would have wrote as square root 7. I like to do square root 9, square root 2, square root x, 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 x. Alright, you know there's 5 of them. That's not an even number because we'll have groups of 2 here. So I'm going to have 1 left over. So I probably would have wrote this as square root 7. Square root of 9 is 3. I have an x and an x on the outside times the square root. There's still a 2x inside. This is on the inside. This is on the inside. This is coming out as a 3. So now I have. So then that means I need a square root 2x, square root 2x. So I would say this is square root 14x over 3x squared. This circled here. Square root 2x times square root 2x is going to be 2x every single time. Whatever you multiply square roots together, they're going to be it. So this is square root 14x over 6x cubed. Variables aren't fun. Alright, if they're in groups of 2, it's easier. Obviously, I possibly could have made a mistake there, so just check it, make sure it makes sense to you before you do the practice. Here's this period of a pendulum. Is the time required for it to make one complete swing back and forth. So this is a good science problem. Alright, 2 pi, and then its length over 32. Well, good news here. Our length is 6. So our pendulum swings at 2 pi square root 6 over 32. I'm dividing both those by 2. They're both even numbers. Pendulum period, pendulum period 2 pi. This is going to be a square root of 3 over 16. What I like about that is this, we don't have to rationalize. Square root 3 over the square root of 16 is 4. Now remember, this would be like this, multiply straight across those fractions. I would have said this is the period of time is 2 pi square root 3 over 4. With fractions, we've been multiplying straight across. This would cancel out, be a 2. This would cancel out, be a 1. I would argue that this is pi square root 3 over 2. Now it says find the period. That is 2 irrational numbers multiplied together. They're still an irrational number. But if it tells me to find the period, I would put this in my calculator, and you guys should approximate it. That's why I put a squiggly equals, because we're rounding to 2.7 seconds. So the period of time for the pendulum to swim back and forth is 2.7 seconds. And that's an irrational number. Okay. Thanks for listening. Alright. We should be comfortable working with square roots at this point. And if you have some questions, feel free to ask and use academic support as needed. Have a great day.